Let's continue our discussion on finding the single source shortest path. That means from one source, the shortest path to all other nodes is to be found. And in our previous session, we have seen one method. The extension of that method is what we call Dijkstra's method. So here we begin with the source, and to begin, we say that we don't know distance to any other node, so we put all other as infinite. Only the source is known, so the distance from source to itself is 0. So that's where we begin our journey. So the difference between the previous logic and this method is that here we are selecting the shortest node, that is having shortest distance from the source as the next continuation, and while doing so we see what the next node's distance can be and all that. So that's what we were working on. So if this node is u, this node is v, and the distance at v, if it is greater than distance at u plus the path length between u and v. So if this is having greater value compared to this value plus this, then simply revise the with the smaller value. So that's a logic. Then second thing is each node will get only one chance for the extension. So, and how does this work with one chance only? Let's just look at an example and see what makes the things go wrong, or the negative side of the Dijkstra algorithm. Okay, so we have 1 0, all other infinite. That means we are beginning with our journey with node 0. That's our source. So from node 0, we found that there is a path to 1 whose distance is 16, and there is a path to 2 whose distance is 13, and all other still unknown, because from the node 0, 3, 4, 5 are still unconnected directly. So maybe via some other nodes they may get connected, but directly from 0 there is no connection. That's what we are trying to say. Okay, so 0's work is over. Then who is smallest next? 16, 13, infinite, infinite, infinite. Definitely 13 is infinite. 13 is smallest. Therefore, node 2 will be our next choice. So that made 16. This made 13. Okay, node 2 is our next choice. So from node 2, where all we can go to 1. So node 2's distance is 13 plus this path length is 4. So 13 plus 4 is 17, but the direct path we had come directly from 0 is having distance of 16. So via 2 it is making 17, therefore no need to change. So this remains 16 only. Okay, what next? From 2 we can go to 4 also. So 2 to 4. So 13 plus 14, that makes 27. And earlier it was infinite, therefore this becomes 27. And from 2 there is no chance to go to 3 directly, therefore 2 and 3 and 5 are still remaining infinites. So 0 is done, 13 is done, so remaining 16 infinite, 27 infinite. So 16 happens to be the smallest. So node 1 is the next choice for continuation. From node 1 we can go to 2. So 16 plus 10, that makes 26, but we have reached there already in 13. So this new thing will not make any improvement to our work, therefore it's not going to make any difference. So 13 remains as it is. So from there we can go to 3. So 16 plus 12, that makes 28. Okay, then we can't go to 4, so 27 remains as it is. We can't go to 5, so infinite remains as it is. So who all are remaining now? 0, 16, 13 are over. 28, 27 infinite, so 27 is found to be the smaller one. So next node to consider is 4. So from 4 we can go to 3, from 4 we can go to 5. So from 4 if you go to 3, so that's 27 plus 7, that makes 34, whereas we have already reached node 3 in 28. So 27 plus 7 makes 34, so that's already there 28. So no meaning in using this new path, because it's going to be a longer one compared to the earlier one, therefore no change in the previous one. So that's the 16. Then we have included 27. So from 4 we are checking, from 4 we can go to 3, so that doesn't make any change. From 4 we cannot go to 2, so that remains 13. From 4 we cannot go to 1. So from 4 we can go to 5, 27 plus 4, that makes 31. So that's a 31 here. Now who is smaller? 28 is smaller, therefore node 3 comes into action. Now from node 3, if you look at it, you can't go to node 1, you can't go to 0, or you can't go to node 1, so that remains 16. Yes, we can go to node 2, so 28 plus 9, that will make 37, but node 2 we have directly reached in 13, therefore no change. Okay, then from node 3 we can go to node 5, 28 plus 20, that is making 48, so we have reached with 31 already, therefore nothing is to be done. So who is next? Next is 31, that is node 5. So that way we have checked all the nodes and finalized. So in this, what we have done is once it is used, we are not going to update it again. So that's a thing, because this Dijkstra's algorithm was mainly devised for distances, so there can't be any negative distances, and hence it was assumed that all the weights are positive. Therefore if we had selected say 13, then 13 was selected because that was the smallest among all. So anything comes after that has to be greater than 13, and to that this 9 has to be added. That means it is going to be even more than 13, and that way definitely if you try for any other path, any other longer path, the total distance has to be definitely greater than it is, because the weights are positive. So the weights may be negative. So in case of other situations like business, profit and loss are there. So sometimes profit is more, loss is less. So the net is positive. Sometimes profit is less, loss is more, the net is negative. So depending on that, yeah, positive, negatives are possible. So in different cases, when you put them on the graph, so some cases the weights may be negative. Such case, I think this algorithm may fail. Let's see what could happen. Just as a example, instead of plus 10, let's use minus 10 here. So what we did, from 0 we started, so we go to this 16, we go to this 13, then 16, 13, we find minimum is 13, so this is done. Then 13 is minimum, so from 13 we can go to 1, 13 plus 4, 17, already it is 16, so no use, and 13 plus 14 is 27, so we get 27. So that's done. So node 2 is used. Okay, who else next? So after node 2 is used, we have 16, 13 and 27. Right, so the next one is 16. So from 16 you can go to 3 and that makes 28. So from 1 you can go to 3 and that makes 28. But from 1 you can go to 2 also, and 16 minus 10 is going to be 6. But the Dijkstra algorithm says that 13 is already used, so this cannot be updated. This cannot be updated, therefore this is going to remain 13, which is in reality a wrong answer, because the right answer should have been from 0 to the path for 2 is 0 to 1, 1 to 2, and the path length would be 16 minus 10, which is 6. And from 6 then you get 4, that will make it 20. Instead of 27 it will make only 20. So that way the whole situation gets changed, but it is not allowed, and hence this is a drawback of Dijkstra's algorithm. Now if we had allowed the changes, then we would have made this 16 minus 10 as 6, and the next time this 6 plus 14 would have become 20, 20 plus 7 would have become 27. Instead of 28 we could have gone for 27. Then 20 plus 4 instead of 31 would have become 24. So the best route would have been 0 to 1, 1 to 2, 2 to 4, 4 to 5 would be getting you the best route. So 0 to 1, 1 to 2, 2 to 4 and 4 to 5. So 0 to 1 is 16, 1 to 2 is minus 10, 2 to 4 is 14 and 4 to 5 is 4. So what is total? Minus 6 plus 14, 10, minus 6, 16 minus 10 is 6, plus 14 is 20, plus 4 is total 24. 24 would have been the correct answer instead of 31. But Dijkstra's method has not considered negative possibilities. Therefore, it said that if once it is selected, there is no chance of its value reducing by any other path, because that has come earlier. Coming earlier means the things, if you look at it, they keep increasing. So we started with 13, 16, and next time we got 27, 28, the next time we got 31. So if you have a bigger network, then as you continue further, the numbers keep increasing, they cannot come decreasing, because you are moving, it's a physical distance, then as you move away and away, the distance has to increase, it can't reduce. That's the logic of Dijkstra's algorithm, and that's going to be a big problem in the general application. So we can't apply this Dijkstra's algorithm in general, because a general problem may have negative edges. So for that, we need to find some other way out. So please keep watching this. And if you find these videos interesting, so please share with your friends, and please do subscribe and hit the bell button, so that whenever new videos are made available to you, so please you get a notification. So please keep waiting and keep watching. Thank you.